So in this construction, what we wish to do is to draw a line perpendicular to a given line through a given point on the line. So here you can see we have our line and we have a point here marked A, and what we wish to do is to draw a line perpendicular to our given line through the point A. So the first thing we are going to do is we're going to draw a circle centered around the point A. And once we have drawn this circle, the next thing we wish to do is to label the 2 points where this circle intersects our line. Okay, so we've labeled these points B and C. So the next thing we're going to do is draw 2 more circles. We will have one centered around the point B and one centered around the point C. 2 conditions on these circles. The radius of the circles must be the same. So whatever setting you have on the compass when you draw the first circle, keep the compass at the same setting when you draw the second circle. And the second condition is that the radius must be greater than half the distance between the points B and C, because we need these circles to intersect. So we'll draw the circle around the point C first. And now we'll draw a circle of the same radius around the point B. Okay, so what we are going to do is mark this top point of intersection here, where these 2 circles met. So we've labeled that point D, and now we're going to draw a line from A to D, and that is our construction complete. Okay, so that's our construction, and what we want to do now is see why we can say this construction is true or valid. So to enable us to see this, we are going to draw 2 lines, one from C to D and one from B to D, like so. So having drawn these 2 green lines, you can see we now have 2 right-angled triangles. We have the triangle CAD, and over here we will put the triangle BAD. Now the length of the line segment CD is equal to the length of the line segment BD. And we know these are the same because they are radius lines of 2 circles which have the same radius. We have the length of the line AC or CA is equal to the length of the line AB. Again, because these 2 lines are radius lines of a circle. And finally, because CD and DB are the same length, our triangle DCB is an isosceles triangle. So we have the angle DCB is equal to the angle DBC. So what we have here is we have 2 congruent triangles, and they're congruent by side, angle and side. And because they are congruent, that means that the angle DAC must be equal to the angle DAB. And if these 2 angles are equal, then this line AD must be perpendicular, and our proof is complete.